Hey, my name is Luke Monington, and in this video, we're going to be talking about a leaked Google document that came out just a few days ago. This document is very interesting because it looks into some of the strategy of what Google had done in the past, and it looks at some of the current trends that we're seeing in the open source community, where the open source community is advancing very quickly on the large companies like Google and OpenAI. And it predicts a possible change in strategy that Google may be implementing in the coming weeks and months related to these large language models. So I'm going to be reading through the document together with you and providing my commentary as we go. Google starts out by saying, "We have no moat, and neither does OpenAI. We've done a lot of looking over our shoulders at OpenAI. Who will cross the next milestone? What will the next move be? But the most uncomfortable truth is, we aren't positioned to win this arms race, and neither is OpenAI. While we've been squabbling, a third faction has been quietly eating our lunch." And one thing I find very interesting about the way they worded this is that they consider this to be an arms race, an AI arms race. And the way they worded that is a little bit concerning to me because it implies possibly that they're racing towards some AI superiority over another company. And I think a race to AI supremacy can be very risky. And they go on by saying, "I'm talking, of course, about open source. Plainly put, they are lapping us. We have no secret sauce. Our best hope is to learn from and collaborate with what others are doing outside of Google. We should prioritize enabling 3P integrations. People will not pay for a restricted model when free, unrestricted alternatives are comparable in quality. We should consider what our value add really is. And giant models are slowing us down. In the long run, the best models are going to be the ones that can be iterated upon quickly. We should make small variants more than an afterthought, now that we know what is possible with the less than 20 billion parameter regime." And they show this document here, where this is the Llama 13 billion parameter model, open source, and then 2 weeks later with Alpaca 13 billion, and it's doing substantially better. And then Vicuna, 1 week later, doing 92% as good as ChatGPT. And notice that all three of these models are just 13 billion parameters. And ChatGPT, although they didn't announce it, the GPT-4 estimate is around a trillion parameters. So we're seeing these open source models that are just 13 billion parameters able to compete with the largest models that Google and OpenAI are putting out. Even close to a trillion parameter models can be beaten by these 13 billion parameter models that are open source. And so what happened? At the beginning of March, the open source community got their hands on their first really capable foundation model as Meta's Llama was released to the public. It had no instruction or conversation tuning and no RLHF. Nonetheless, the community immediately understood the significance of what they had been given. A tremendous outpouring of innovation followed, with just days between major developments. And the timeline is below, and we'll be going over the timeline too in this video. Here we are barely a month later, and there are variants with instruction tuning, quantization, quality improvements, human evals, multimodality, RLHF, and so on, many of which build upon each other. More importantly, they've solved the scaling problem to the extent that anyone can tinker. Many of the new ideas are from ordinary people. The barrier to entry for training and experimentation dropped from the total output of a major research organization to one person, an evening, and a beefy laptop. And this really hits on a lot of important points where now the open source community is able to do things that are just as good or almost as good as these large research companies at Google and OpenAI, but they're able to do it with substantially fewer parameters, way less computational power, and with just a normal person, someone who may not even be very well versed in machine learning. They're now able to tinker with these models and make improvements. And the improvements are cumulative, where one person's improvement can be added on top of another person's improvement to stack improvements and to end up with a much more mature model in the very end. And this also raises some concerns about regulation because lately in the news, there was an announcement that there's going to be this large investment in AI regulation. And it makes me think a lot about how we will be able to regulate the use of artificial intelligence and artificial superintelligence as we get closer and closer to human level performance, where previously I would have thought that maybe we could regulate these super intelligent models by making sure to control the GPUs and making sure that large quantities of GPUs don't end up in the wrong hands of someone who might do something dangerous with it. But if we are able to get similar performance from models that can be trained with just 13 billion parameters, that means that these super intelligent models may be able to be run on a single laptop entirely locally. And they would be able to be fine tuned as well entirely locally by a single person who is not even an expert in artificial intelligence. And so that brings a lot of ideas to mind about how are we going to be able to regulate this? Or is it even possible to be able to regulate AI superintelligence now that we're seeing these trends towards models that are smaller and smaller performing way better than we ever thought possible? And so the article goes on by saying why we could have seen it coming. In many ways, this shouldn't be a surprise to anyone. The current renaissance in open source LLMs comes hot on the heels of a renaissance in image generation. The similarities are not lost on the community, with many calling this the stable diffusion moment for LLMs. In both cases, low-cost public involvement was enabled by a vastly cheaper mechanism for fine-tuning called low rank adaptation, or LoRA, combined with a significant breakthrough in scale, latent diffusion for image synthesis and chinchilla for LLMs. In both cases, access to a sufficiently high-quality model kicked off a flurry of ideas and iteration from individuals and institutions around the world. In both cases, this quickly outpaced the larger players. These contributions were pivotal in the image generation space, setting stable diffusion on a different path from DALL-E. Having an open model led to product integrations, marketplaces, user interfaces, and innovations that didn't happen for DALL-E. This is very interesting as well, because when they talk about user interfaces, there's all these user interfaces. There's a local user interface for stable diffusion that makes it very easy for any person to go onto the repo and get it up and running, and to very quickly be able to take any computer vision model from the Stable Diffusion family and from some of the other families as well, and just download it off of the internet into the models folder and be able to use it immediately. And so this really makes it way easier for a normal person to be able to get their hands on these incredibly powerful models and start tinkering with them and getting some outputs and seeing how they perform. And so the effect was palatable. Rapid domination in terms of cultural impact versus the OpenAI solution, which became increasingly irrelevant. Whether the same thing will happen for LLMs remains to be seen, but the broad structural elements are the same. Another interesting point as well on how the open model led to product integrations, marketplaces, and so on is that with these open source models, there's entire websites that have been created where users can just upload any model they want to and share their model with the community. So now there's places where there's thousands of open source stable diffusion models that a user could just go find a specific type of model for a specific use case that they want to work on and just download that and start generating images or generating text within a few minutes. It's incredibly fast. And so, what we missed. The innovations that powered open source's recent successes directly solve problems we're still struggling with. Paying more attention to their work could help us to avoid reinventing the wheel. LoRA is an incredibly powerful technique we should probably be paying more attention to. LoRA works by representing model updates as low-rank factorizations, which reduces the size of the update matrices by a factor of up to several thousand. This allows model fine-tuning at a fraction of the cost and time. Being able to personalize a language model in a few hours on consumer hardware is a big deal, particularly for aspirations that involve incorporating new and diverse knowledge in near real time. The fact that this technology exists is underexploited inside Google, even though it directly impacts some of our most ambitious projects. And so this introduction of LoRa is absolutely incredible that now we have this new way of fine-tuning the models that uses way less computational power, way less size, It makes it so that you can take one of these models and just fine tune it on whatever use case that they have. Retraining models from scratch is the hard path. And part of what makes LoRA so effective is, like other forms of fine tuning, it's stackable. Improvements like instruction tuning can be applied and then leveraged as other contributions add on dialogue or reasoning or tool use. While the individual fine tunings are low rank, their sum need not be, allowing full rank updates to the model to accumulate over time. And so this is another interesting topic as well, that these fine-tuning optimizations that the open source community is finding stack upon each other. So what one person makes can then be incorporated into the work that another person is using to get further optimizations and further improvements. And by stacking these improvements, the final model is going to be much more mature and high performing than what it initially started with. And so this means that as new and better data sets and tasks become available, the model can be cheaply kept up to date without ever having to pay the cost of a full run. By contrast, training giant models from scratch not only throws away all the pre-training, but also any iterative improvements that have been made on top. In the open source world, it doesn't take long before these improvements dominate, making a full retrain extremely costly. We should be thoughtful about whether each new application or idea really needs a whole new model. If we really do have major architectural improvements that preclude directly reusing model weights, then we should reinvest in more aggressive forms of distillation that allow us to retain as much of the previous generation's capabilities as possible. Large models aren't more capable in the long run if we can iterate faster on smaller models. And this is what the real strength is of the open source community, is that since the open source community doesn't have this large amount of computational power to be able to train models on 10 or 100 or 1,000 GPUs, they're finding ways to train models and get models working on a home laptop that a regular person has access to. And because they're able to get these models working locally on a normal laptop, that means they're able to iterate much more quickly on it. And what Google is saying here is that they're missing out on all of those optimizations that the open source community is able to generate because Google is too focused on these large models and retraining from scratch. And so this is the introduction of a potential strategic shift that Google may be making in the future. Indeed, in terms of engineer hours, the pace of improvement from these models vastly outstrips what we can do with our largest variants, and the best are already largely indistinguishable from ChatGPT. Focusing on maintaining some of the largest models on the planet actually puts us at a disadvantage. Data quality scales better than data size. Many of these projects are saving time by training on small, highly curated data sets. This suggests that there is some flexibility in data scaling laws. The existence of such data sets follows from the line of thinking, data doesn't do what you think, and they are rapidly becoming the standard way to do training outside of Google. These data sets are built using synthetic methods, such as filtering the best responses from an existing model and scavenging from other projects, neither of which are dominant at Google. Fortunately, these high-quality datasets are open source, so they are free to use. This also touches on the point that a lot of outputs from some of the best models can then be used as training data to fine-tune some of these smaller models. So what they're talking about with filtering the best responses from an existing model is that some of these models were actually trained on GPT-4 outputs. And you might be thinking, well, how did they get GPT-4 outputs? Only OpenAI has that. Well, the best GPT-4 outputs were just put onto Reddit. And so now they're able to curate a data set of the best OpenAI outputs by just taking those outputs off of Reddit or finding other ways to generate the data set. And the same thing with image generation, where you can use a more powerful, larger model to generate the images and then take those images and use those images as the training data in order to build out a more powerful, smaller model. And so the article goes on by saying that directly competing with open source is a losing proposition. This recent progress has direct, immediate implications for our business strategy. Who would pay Google for a product with usage restrictions if there's a free, high quality alternative without them? And should we not expect to be able to catch up? The modern internet runs on open source for a reason. Open source has some significant advantages that we cannot replicate. This really touches on the point that a lot of people have been talking about, that they maybe don't want to be spending $20 a month on the OpenAI ChatGPT to be able to interact with it and potentially have their data be used. There was the recent data privacy update to OpenAI's ChatGPT where the user can flip a switch to not have their chats saved and not have their data saved as well. But why would someone want to put their data over on the internet and also have to deal with all of the ChatGPT restrictions when they can just get a model that is comparable or potentially even better very soon, working entirely locally on their own data set with no restrictions and without any concerns for data privacy. So the article goes on by saying we need them more than they need us. Keeping our technology secret was always a tenuous proposition. Google researchers are leaving for other companies on a regular cadence, so we can assume that they know everything we know and will continue to for as long as that pipeline is open. But holding on to a competitive advantage in technology becomes even harder now that the cutting edge in research in LLMs is affordable. Research institutions all over the world are building on each other's work, exploring the solution space in a breadth first way that far outstrips our own capacity. We can try to hold tightly to our secrets while outside innovation dilutes their value, or we can try to learn from each other. Individuals are not constrained by licenses to the same degree as corporations. Much of this innovation is happening on top of the leaked model weights from Meta. While this will inevitably change as truly open models get better, the point is that they don't have to wait. The legal cover afforded by personal use and the impracticality of prosecuting individuals means that individuals are getting access to these technologies while they're hot. Being your own customer means that you understand the use case. Browsing through the models that people are creating in the image generation space, there is vast outpouring of creativity from anime generators to HDR landscapes. These models are used and created by people who are deeply immersed in their particular subgenre, lending to a depth of knowledge and empathy that we cannot hope to match. And this really touches on that as soon as the model gets released to the wild, it's a lot more difficult to prosecute individuals that are getting access to the models. So they're just able to use it and they have this subject matter expertise on a particular use case. They may have a particular passion that they really enjoy. And so they can take the model and combine it with their passion in order to generate a model that's been curated in a way that these big companies could never have done. Paradoxically, the one clear winner in all of this is Meta, because the leaked model was theirs. They have effectively garnered an entire planet's worth of free labor. Since most open source innovation is happening on top of their architecture, there's nothing stopping them from directly incorporating it into their products. The value of owning the ecosystem cannot be overstated. Google itself has successfully used this paradigm in its open source offerings like Chrome and Android. By owning the platform where innovation happens, Google cements itself as a thought leader and direction setter, earning the ability to shape the narrative on ideas that are larger than itself. So this is coming on the point that before, big tech companies like Google and OpenAI have been very closed off with their models and not releasing them into the wild. But now Google is considering a strategic shift where they're seeing that they can't really compete with the open source community because the open source community can implement so many ideas so quickly and iterate so quickly. And so they're considering possibly finding a way to lead the open source community and use the open source community to their advantage. And so they go on by saying the more tightly we control our models, the more attractive we make open alternatives. Google and OpenAI have both gravitated defensively towards release patterns that allow them to retain tight control over how their models are used, but this control is a fiction. Anyone seeking to use LLMs for unsanctioned purposes can simply take their pick of the freely available models. Google should establish itself as a leader in the open source community, taking the lead by cooperating with rather than ignoring the broader conversation. This probably means taking some uncomfortable steps like publishing the model weights for small ULM variants. This necessarily means relinquishing some control over our models, but this compromise is inevitable. We cannot hope to both drive innovation and control it. And another interesting point on this, going back to the initial letter to pause AI development for 6 months, one of the recommendations was to hold the developers of the large AI model liable for the model's potential misuses. And so, while that idea was a really good idea when the letter was released a few months ago, it makes me wonder if maybe that is not the most practical now, since even open source communities, even a person working on their laptop can fine tune and build out a model that is on the same level as something like ChatGPT. And when Google talks about releasing a ULM variant out to the open source community, it necessarily means that they're relinquishing control over how it's used, and potentially some bad actors might be able to use the model in some ways that could be harmful. And so that brings to mind whether Google would be liable for the misuse of their models that they release to the open source community. And so for the epilogue, what about OpenAI? All of this talk about open source can feel unfair given OpenAI's current closed policy. Why do we have to share if they won't? But the fact of the matter is that we are already sharing everything with them in the form of the steady flow of poached senior researchers. Until we stem that tide, secrecy is a moot point. And in the end, OpenAI doesn't matter. They're making the same mistakes we are in their posture relative to open source, and their ability to maintain an edge is necessarily in question. Open source alternatives can and will eventually eclipse them unless they change their stance. In this respect, at least we can make the first move. And now let's get into the actual timeline. And it's incredible to see how quickly these changes have been happening and how quickly the developments have been coming out. So in February 24th, that's where Llama was launched from Meta. And then less than a week later, that model was leaked into the public on 4chan. And the impact to the community cannot be overstated. Existing licenses prevent it from being used for commercial purposes, but suddenly anyone is able to experiment. And it's very interesting. This marks the first time ever where a model was leaked out, and it brings to mind some additional considerations about possibly doing some watermarking to the model, because ultimately this llama model was released and nobody even knows who did the leaking. And in the future, if we have much more powerful models, we would want to be able to know who leaked the model in order to hold them accountable. And then on March 12th, a person was able to get a large language model working on a Raspberry Pi. It was running too slow to be practical, but that set the stage for an onslaught of minification efforts. So now that people saw that you could put this model onto a Raspberry Pi, now all of these other people are competing to see who else can get a model working on a home setup, on something smaller. On March 13th, one day later, Stanford releases Alpaca, which adds instruction tuning to Llama. More important than the actual weights, however, was the Alpaca LoRA repo, which used low rank fine tuning to do the training within hours on a single RTX 4090. And so the RTX 4090 is the best GPU right now that NVIDIA came out with for 2023. So it's a pretty powerful GPU, but it's a home setup. It's a home GPU. And so this is really significant because now this is showing that the model can be fine-tuned in just a few hours on a home setup. Then on March 18th, suddenly it's fast. Someone managed to find a way to use 4-bit quantization to run Llama on a MacBook CPU. So now they don't even need to use a GPU in order to run these LLMs. There's a way to do it with just a CPU. A day later, a 13 billion parameter model achieves parity with Bard. That means it's on the same level as Bard, and that's the Vicuna model that came out. Then on March 25th, the GPT-4 All is released, which is both a model and also an ecosystem. And so for the first time, we're seeing models like Vicuna gathered in one place. Then on March 28th, the open source GPT-3 came out. And what's significant about this is that this is the first time that an open source model was fine-tuned completely from scratch. So now they don't even need Meta's Llama in order to make the improvements. Now there's a fully open source model that people can use. Then, on the same day, someone figured out how to do multimodal training in 1 hour using a parameter efficient fine tuning technique. The Llama adapter introduces instruction tuning and multimodality in 1 hour of training. Impressively, they do so with just 1.2 million learnable parameters, and the model achieves a new state of the art on multimodal science QA. Then, on April 3rd, Now humans can't even tell the difference between a regular 13 billion parameter model and ChatGPT. So now we're really getting to the point where these models are getting to the same level of performance as the large closed off ChatGPT from OpenAI. And then finally on April 15th, now we have open source RLHF at ChatGPT levels. So Open Assistant launches a model and more importantly, a dataset for alignment via RLHF. This model is close to ChatGPT in terms of human preference. In addition to Llama, they show that this dataset can be applied to Pythia 12 billion, giving people the option to use a fully open stack to run the model. Moreover, because the dataset is publicly available, it takes RLHF from unachievable to cheap and easy for small experimenters. So now regular people are able to use the RLHF in order to do model alignment. So what we're seeing here is that things are moving incredibly quickly. As soon as the open source community has an idea, and as soon as they're able to get their hands on a model, suddenly it opens the door for all of these new developments and iterative improvements, and these improvements are stacking on top of each other. And the large companies like Google and OpenAI are starting to notice that they aren't going to be able to compete with the open source community. And so it'll be very interesting to see how Google and OpenAI and Meta and the strategically placing themselves over the next few months, considering that the open source community is able to create models that are nearly on the same level, with significantly less money and computational power. And so that's it for this article. I would encourage you to go read this article yourself. I'll leave the link in the description, and I'll see you in the next video.